In today's lesson, we are going to be doing a little bit of an investigation called Apples and Evergreens. So, the way it works, a farmer plants apple trees in a square pattern. In order to protect the trees from the wind, he plants evergreens all around the orchard. The diagram that I'm going to show you next illustrates the pattern of apple trees and evergreens for any number n of rows of apple trees. So depending on the number of rows of apple trees I have, my pattern is going to change. So here is my pattern for different number of rows, from 1, 2, 3, and 4 rows of apple trees. So we can see the pattern here, or we can see visually the pattern here. So again, you may want to take a picture of this or refer to the handout because we are going to kind of go through some questions. So in class, you would be working on this in groups. If you're doing this at home or you're revisiting this, again, I'm just going to show you the questions and get you to think about it, and then we're going to jump to the summary. So if you want to pause the video after each question that I show you to try to work this out, I do recommend that. Otherwise, you can just sit tight and we'll get to the summary. So here's our pattern of both evergreens and apple trees. And the first question is, what would n equals 6 look like? So I had patterns 1 to 4, or rows of apple trees 1 to 4. What would n equals 6 look like if I had 6 rows of apple trees? So again, you can pause the video, draw it out if you'd like. Then moving on to the next question. For what value of n will the number of evergreens equal 104 or 184? So in this case, you might need to determine a rule for the evergreens. Or you recognize what the pattern is and you keep on moving on to the next value of n. Next position, next position, next position. But a rule might be easier. In which case, or in how many rows or which value of n, is the number of apple trees equal to 1024? So how many rows of apple trees would my pattern need to have in order to have 124 or 1024 apple trees? How many apple trees and evergreens are there when n equals 48? So this one, it might be a little bit too hard to go through and just continue the pattern, so we might need to come up with a rule for both apple trees and evergreens. So you might have to take a look at that visual pattern, maybe put it into a table, and try to figure out what the rule is. Is there a case in which the number of apple trees is double to the number of evergreens? What about triple? Is there a case where there's a triple, where the number of apple trees is triple to the number of evergreens? In which case are there 20 more apple trees than there are evergreens? And then what about 30 more? Right, so just some extension questions. So the last two may be a bit challenging, so if you don't quite get them, that's okay. It's more of just an extension question, looking at the rules. What is the difference in the growth pattern of the apple trees compared to the evergreen trees? Right? So we are going to go back and look at this because we are going to take a look at the different patterns. So when we get into the summary, before I even get into this, I'm going to go through and create my table of values for n, number of evergreens, and the number of apple trees. So if I go back, scroll all the way back up, if I look at my first one, I have 1 apple, and evergreens I have 1, 2, 3, 4, 5, 6, 7, 8. In the next one, I have 4 apples, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And E equals 16. Pattern number 3, I have 9 apple trees. For evergreens, I have 1, 2, 3, 4, 5, 6, 7, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Hopefully we're starting to see a pattern now. Apple trees, I have 16. Evergreens, I have 32. So if I go back from that now, I can go in and fill in my table. So if I'm looking at apple trees first, so 1, 2, 3, 4, 5, 6, 7, at 8, 16, 24, 32, 40, I'm going to guess, 48, 56. For the evergreens, I had, or for the apples, I had 1, 2, 3, 4, 5, 6, 7. I had 1, 4, 9, 16. I know the pattern, so it's going to be 25, 36, 49. So let's see if we can kind of go back, and we'll come back to this table. So, first question asks, which is linear and which is nonlinear? Well, looking at the tables, if we wanted to graph this, which we could, and we will later, we should see that the evergreens are increasing by a consistent amount. And we should determine that that is linear. The apple trees, however, are not increasing by a consistent amount. They're not increasing by the same amount every time. So they are nonlinear. What would the rule be? Well, we've just learned this in the previous lesson. If I look at what the change is from 8 to 16, that's a change of 8. From 16 to 24, that's a change of 8. From 24 to 32, that's a change of 8. Seems to be a change of 8 every time I add a row of apple trees. If I worked backwards, as we've learned before to do, to position 0, I would also have 0 evergreens. No apple trees, no evergreens needed. So in this case, my rule is just y equals 8x. 8 is my multiplier, which I found by seeing what the change is, which we can also call the first differences. So if I know what my y values are changing by, from 8 to 16, that's a change of 8. From 16 to 24, that's a change of 8. This change is also called the first differences. If I look at my second one, the apple trees, well, from 1 to 4, I have a change of 3. From 4 to 9, I have a change of 5. Then a change of 7, then 9, then 11, and then 13. So I'm not changing by a consistent amount. Right? My first differences, another word for the change in y when we go up by 1, is not consistent. But what would my rule be? You can take a look at the pattern. It's not going to be a linear pattern, but if you work through it, you should find the pattern is y equals x squared. However many rows of apple trees we have, we square that, and that tells us how many apple trees we have. How many rows squared gives us the number of apple trees. So let's graph this as well. So for the apple trees, or the evergreens, we start off at 0, 8, 16, 24, 32, 40. Can't really graph anymore. For the apple trees, 0, 1, 4, 9, 16. I can't really even do 25. So if we connect these with the line, we can see the difference between the two. what we can see, hopefully we can clearly see which one is linear and which one is not. And if we summarize the growth pattern, the evergreens, they grow or grows by a constant amount. And for the apple trees, you say it grows rapidly by inconsistent amounts. So the big thing by going through this investigation, hopefully we have a summary now of the differences between linear and nonlinear patterns. So for linear patterns, the key thing is that it forms that general equation, which we've talked about before, and you'll probably be sick of it by the end, y equals mx plus b. That general form tells us it's linear. For nonlinear, the key thing is the exponent. So that exponent of 2 tells us it's nonlinear. So anytime we see an exponent in our rule, it would be nonlinear. Looking at a table of values, we want to check the first differences. We want to see what is the change in x or the change in y by. In the first one, they're all 8. They're all the same. In the second one, they're different. They're not the same. So if we're looking for a linear pattern from a table of values, the first differences, or what the y values change by, should be consistent. When we look at the x or the nonlinear one, the first differences or the change in y is not consistent. It's not the same. For a graph, relatively straightforward, linear, straight line. For nonlinear, we have a curved line. And for the description of the pattern of growth, again, it grows by a constant amount, so that idea that we're increasing or decreasing by the same amount. Whereas if it's nonlinear, in this case, it grows rapidly by inconsistent amounts. It could decrease rapidly by inconsistent amounts or different amounts every time, again, depending on what the pattern is. So the main thing from this investigation, aside from going through and answering the questions and looking at patterns, the big thing is just being able to now summarize the difference between linear and nonlinear patterns, which we do have a summary specific to this apples and evergreens, but this could apply to any linear or nonlinear pattern.